Hi, my name is Jack Bennett from Organic Chemistry Lab, and for my project, I will be showing you how kombucha brewing is very related to chemistry and what we've been learning so far. So right here, I've got a half a gallon of black tea. I've been letting it boil for a little while, and it's been steeping for a while, so I believe it's good to go. Right here, I've got a cup of turbinado cane sugar. Now this turbinado cane sugar is primarily made of sucrose. And as we know, sucrose is a polymer made of glucose and fructose. So I'm adding that to the tea right now, and since it's hot, the idea is to dissolve it thoroughly and completely. Get that sucrose all the way dissolved. And it'll take a little while to make sure it's thoroughly dissolved. It has to be in order to guarantee maximum reaction, because that's essentially what brewing kombucha is. It's just one big drawn-out reaction. And the name of that reaction is fermentation. Alright, this looks pretty good. Come with me, I'm going to show you where our reaction will be taking place while this sits for a bit. This way. Oh, and my mom's been filming this, so she's doing a great job. So right here, please come close, you can see this big old glass chamber, and it's filled with a brown liquid, and floating on top of it is that white congealed mass. And that's what we call a SCOBY. SCOBY stands for Symbiotic Culture of Bacteria and Yeast, and that's essentially what it is. It's a bunch of yeast and bacteria that's been growing in this solution. And that solution is actually kombucha I brewed in the past. Let's head back to the kitchen. So lately we've been talking about how chemistry uses a lot of enzymes and coenzymes to make reactions happen. And that's what the SCOBY is. That's how it acts. It will, so now that this sugar has been thoroughly dissolved, yep. It still needs a little more time to fully dissolve. But what's going to happen is, once I cool this tea solution, it'll become super saturated with all that sucrose sugar. I will then add it to that chamber we just saw, and I will leave it there for a few days. And what will happen is the sucrose will be broken up by the yeast in the SCOBY into glucose and fructose, its two main components. And once that happens, the bacteria in the SCOBY is going to take the glucose and it's going to break it down into acetic acid. And acetic acid is something you find a lot in vinegar, and that's correct, because the kombucha is going to gain a slightly vinegary taste from that acetic acid. The fructose will be broken down by bacteria as well into lactic acid and other acids as well. I get a lot of questions as to why kombucha is not alcoholic. And the thing is, it can be alcoholic, but in case you didn't notice, the chamber I'm brewing it in is covered with a cloth that lets air through, but it doesn't let any crud through. And that's important because oxygen has to be allowed to enter the solution in order for this fermentation to occur. By allowing oxygen to enter, we ensure that the fructose doesn't get further broken down and converted into ethanol, or the acetic acid could also be converted into ethanol if there's a lack of oxygen. Yes, and that's very important that it doesn't do that. And it's also very important because if we have ethanol in our solution, it will become alcoholic, and I'm too young to be doing that.